Hi, today we'll be talking about flaw detection. This is an this is a flaw detector probe, and this is a cable, a PNC to Limo 1 cable. And the way this works is, if we have this, let's say, steel bar, the wave will propagate. If I put the detector in here, the wave will propagate all the way, the sound wave will propagate all the way to the end of the steel bar and hit the interface and then come back. So let's say this bar is about 20 inches. I'll set my range to 20 inches. I'm not sure if it's 20 inches, but I'm just guessing. Put a couplant material, and this material will prevent any air gaps between the probe and the bar. Now I increase the gain. And as you can see, I increase the gain looking for this peak, this peak I'm looking for. If I go if I choose a gate, and this is the gate, change its position until the gate hits the first echo, then this indication will tell me how long is this steel bar, because the first echo is the echo coming back from the bar, from the end of the other interface of the bar, and this echo is indicating a length of the bar of 13 inches, 0.2. We can make sure that this is the correct length. I'll just make my gate smaller, and now it's saying it's 13.2 inches. Let's go ahead and measure that. So if I measure this, as you can see, it is about 13 inches in length. Now let's get another bar which is at the same length, but now this bar has an anomaly, a crack in it. And let's see if we put the probe, will it detect the anomaly? Will it be able to detect the anomaly? So if I put a couplant on there, on the end of the bar, as you can see, the echo has become at a different position. I change my gate until I'm able to catch that echo. As you can see, the echo has a very lower amplitude, so I increase my gain, and now I have tried to catch that echo with my gate, and it's saying the echo is coming back at a distance at 7.7 inches. So there is an anomaly or a discontinuity, which is this discontinuity, and it should be at 7.7 inches. Let's go ahead and measure that. As you can see, it is almost at that distance, 7.7 inches. Now these settings, the accuracy of these numbers that we get depends on the calibration that we do. This is a calibration block, and what it has a specified thickness, half an inch, 0.4 inches, 0.3 inches. I'll use my probe to measure the thickness, and this is made of steel, so I use my probe to measure change the range to be in the range of half an inch. Okay, change the gain, and I go to my gate, and I should have a distance in the gate and it's saying it's half an inch. Now what I do is to calibrate the device. There is some I should make sure that this number is showing up as half an inch. Since I already know that my calibration block is half an inch thick, so I will change the probe delay until I get exactly half an inch, or as close as possible. Now the probe delay is the delay that is in the cable and the delay in the probe itself. By calibrating that, I have a better calibration for the device, and I get accurate numbers. Now there is another kind of calibration, which is the calibration from from distant amplitude correction, and that curve, the distant amplitude correction curve, is something like this. These curves in here, what do they show is that if you have two anomalies with the same size but at different locations, they should show up on the same curve. And that's another type of calibration called distant amplitude curve. That's about it. There are more thoughts on calibration, but we'll talk about it later. Thank you.